Hello. So it's time to introduce a really kind of a cool, handy tool for electronics, which is the breadboard. All right. And I can't predict exactly which breadboard you're going to end up with. So I've brought three basic boards here because I think you could probably end up with any one of these three depending on where you ordered it from, what country you live in, or whatever. So these are the three basic styles that tend to come with various electronic kits. One is this little half board, and a very common other platform is these 830 point boards. Now these two boards are, well, they're very similar, but they're also significantly different, all right? And it can be subtle at first. When you look at it, you'll see that this blue line right here has a gap, and this red line here has a gap. That means that these are not connected to these. There is a gap, an electrical gap between this group of five and this group of five. Whereas this kind of board, they are in fact all connected. It's a continuous red line and a continuous blue line. And if I stick a wire in this hole, it will actually appear in this hole. Okay? And I think probably the best way to show you how this actually works is to introduce Tinkercad, which has some really nice features and diagrams that we can work with. And I'm going to encourage you all to create an account here. Now, what I did here to get to it is I just simply searched Tinkercad in Google, and this comes up first. I'm sure it will for you as well. And I'm going to go ahead and click it. Now, I've already created an account, so there's a really good chance that this is going to launch directly into my account. If you haven't, you're going to have to create an account. And I believe it goes pretty smoothly and easily if you simply allow Google or whatever platform you're using to do it for you. But you can create an account with any email address and password. You'll be able to actually do it. The reason to do it is that it's all free. There's really no hitch. I'm going to start posting some of these code and some illustrations and examples. You'll be able to have links to it. You'll be able to actually just copy and paste my code. It'll make your job a lot easier moving forward. And you'll be able to actually test your own designs if you want to. If something doesn't work, you can test it in Tinkercad and see whether or not it works on the screen. And if it does, well, then you know that the problem you have is in hardware. So you have to just fiddle with your hardware to get it going. And it works both ways. So it's a really handy resource. However, I will caution, it is somewhat flawed. Sometimes it's heavily used. We've had circumstances where things just don't quite work right probably because of heavy use. And just be aware of the fact that it is a freeware that is, under load right now, especially with this pandemic. So when you open it up, of course, you can see I've already created an account. It tends to default to these 3D designs. We'll probably play with this later on, hopefully when we get face-to-face in class. We'll maybe design some stuff in Tinkercad as well as some other software, and we can use it to make things in the 3D printer. But what we want to do is we want to work with circuits. So I'm going to click on that. And if I click on circuits, I've got lots of circuits that are here. You'll see that some of them are public and some are private. All right. So the ones that are public, I'm going to go ahead and release. You'll be able to have access to them, and you'll be able to just watch them work and copy the code. Some are private, where I'm actually building things and testing it. And you'll have the same issue on your computer when you do it. And you'll also notice that some of these have very clever names. Tinkercad will just auto-generate a name, which is kind of unique. And unless I rename it, which you can do, something logical like I've done here, it'll be kind of unique and standalone. So what I want to do right now is actually want to create a new circuit because I'm going to show us the breadboard and where to get to these 830 point breadboards, because I'm going to suspect you're going to get one of these 830 point, the longer ones. And it takes a moment. Then the default is to go to basics, okay? And basics is great. It has all the basic components, including the Arduino. But the problem is it only has a small breadboard, and that's likely not what you've got. So I'm actually going to click on this down arrow and I'm going to go with all. And then from here, you can see I got lots and lots of components, lots of things we can play with. Many of them we will. And I can get to the breadboard. I'm going to click on it and then click on my screen. And it should appear here in just a moment. My computer's quite slow when I'm trying to shoot videos and broadcast at the same time. There we go. Alright, so if we look at this breadboard, what's nice about it is, I'm going to zoom in quite a bit. You can see that if I hover with my mouse here, that this hole is connected already below the board to these other ones. Okay? So this is connected to that. This whole column is in fact connected. And this column is connected. And this column is connected. But this is not connected to this. Alright? So on yours there's probably a depression here. It's called the IC gap. These are not connected to each other. They're only connected in groups of 5. Now on these buses, okay, on the outside of the board, this is where we have to pay attention. See the center of this? On the board that's provided in Tinkercad, it assumes it's connected. So this is connected to that. And this is connected to that. So this group of 5 is connected to this group of 5, which is connected to this group of 5, which is connected all the way across the board. That may not be the case. Alright? So let's look back over at these boards. Remember I said this one here has the gap is not connected. So let's see how it works. In both cases they have an adhesive material in the back. I've ripped it off completely on this other board so that we can see the way it's actually manufactured. These metal strips are conductive. So every group of 5, like going down column 25, these are all connected to the same metal strip. Alright? So an electron that gets stuck in the hole here is easily going to be able to transfer to an electron here. But if we look at this center strip, I'm going to have to mess around with my focus a little bit. You can see that this edge here, these are not connected. There's a gap. Okay? So electrons cannot make it from here to there because they're not physically connected. So all of these are physically connected and all of these are physically connected, but these are not connected to this. So flipping the board over, all of these red holes are connected together, but they are not connected from here to here. Okay? Likewise, all of these blues are connected, but they are not connected from here to here. On this board, if I were to rip the gap off, we would find that this is in fact connected to this, alright, and they are all continuous. So it's important to look at your board and understand the way it's made, and hopefully it'll be clearly labeled like it is here with this interrupted color gap versus a continuous color gap. Okay. The small board doesn't matter. They're all connected. So all the ones closest to the blue are connected. All the ones that are closest to the red connected. And this board makes perfect sense. All groups of 5 are connected, and these are not connected to these across the IC gap. Just like you see on this board here, these are not connected to these because there's no metal down this center strip. So this video is a little long, but hopefully it was informative, and go ahead and make sure that you do install Tinkercad or have access to it, because I think you're going to find it saves a ton of time when you're able to just copy and paste code and be able to test and demonstrate your code functionality in software, and then once again in the real world. So hopefully I will see you again soon, and well, I'll see you soon.